I'm going to take a couple minutes here to talk about the mean value theorem, and really the question we're answering here is, what does the average rate of change of like an interval tell us? So the mean value theorem, it's got this big, long, complicated introduction that just sets the conditions, and it says let f be a continuous function over the closed interval a to b and the differentiable over the open interval a to b. So that just means that we're including the endpoints for it being continuous, but we don't necessarily care if it's differentiable on those endpoints. Then we know that there exists at least one point C on AB such that we have this expression stay true. So the derivative at C equals f of b minus f of a over b minus a. So in other words, there's at least one point C where the average, where there's at least one point C where the slope is equal to the average slope. And we can kind of see this and think about it logically from imagining a function. So if the function is continuous, you see that blue line kind of running through here, then the average slope is this middle dotted line right here. So that's the average slope between the endpoints. Now, there's got to be at least one point where the slope is equal to the average slope. So if you had the entire function like this, then all the points would have the same slope as the average slope. But if you go too low, like if you start off with a lower slope, then eventually at some point it has to curve up and become steeper than the average and have at least this one point where it matches. Same if we start too steep, eventually we're going to have to slow down and have a lower slope. And that means we've got at least one point here where the average slope is equal to the slope at that point. And if we have something like that blue line drawn originally, then we end up with 2 points because we went from too low to too steep back to too low again. And so you kind of get that idea going along like that. We also have this special theorem, Rolle's theorem, and this is just the mean value theorem where the endpoints are equal. So in other words, f of a equals f of b. And that means there's some point where f of c equals 0. So this is just saying if the endpoints are identical, then there's got to be somewhere where the slope is 0. It doesn't need to be known separately from the mean value theorem, but since it has a special name, I thought I'd point it out.